Greetings from the Hermitage and welcome to this presentation on calculating the volume of a cone. But first we need to get a little background information out of the way. First, a cone looks like this, and the formula for the volume of a cone is pi r squared h, the whole quantity divided by 3. And what we have essentially is a circle with kind of a triangular shape on top of it. The base of the cone is the circle, and the distance from the center of the circle to the circumference is called the radius. And as a reminder, the area of a circle is pi r squared. And if we take the formula for the area of the circle and put into the formula for the volume of a cone, it'll reduce to the volume equals the area times the height of the cone, the quantity divided by 3. In the previous slide, we saw that the volume equals the area times the height divided by 3. And as a reminder, whenever we get an area, it'll have units of length squared. So if we're talking about centimeters, it would be centimeters times centimeters. You can see that in the area of a circle, that's pi times r, where r will be given in centimeters in this case. So that would be centimeters times centimeters, and whatever the number is in front of the units, and we'd get centimeters squared. Likewise, the volume is length cubed, and if we're using centimeters, we'd have centimeters times centimeters times centimeters equals centimeters cubed. And in general, we get something that looks like this. The volume of a cone is going to be the area of the base times the height, the quantity divided by 3. Continuing on with the background information, to solve for the volume, we'll start with the formula. A formula is an equation that just has letters and symbols in it. We'll be given a value for r. We'll be given a value for the height. And you'll notice that this entire thing from here to here is just a system of equations. And we'll be using the substitution method to complete the calculations. What that means is we'll substitute whatever value we have for r and whatever value we have for h into the formula for the volume of the cone. It's always good whenever you're working with formulas like this to keep somewhere nearby a visual to help you understand what's going on. So we start with pi r squared h over 3. That's the formula. We're given, in this case, that the radius of the base equals 5 centimeters. The height equals 6 centimeters. So we have R here, which is 5 centimeters, and the height is 6 centimeters. At this point, we'll take this information, the number and the units, and put into the formula. That gives us this. Notice that whenever I replaced R, I kept the units with it, and we square the entire thing. Once again, when we replaced H with 6 centimeters, we kept the units with it. This next step, we do some simplification. We square 5 centimeters, the whole quantity, the 5 and the centimeters. 5 squared is 25. Centimeters squared is centimeters squared. And then we times that by 6 centimeters. At this point, since you have a denominator, to keep the number smaller and maybe to simplify your calculations a little bit, we look for a number in the numerator that we can divide by the denominator. In this case, we see that 6 can be divided by 3. That will give us 2. That leaves us something like this. At this point, we can multiply the numbers together. We can just rearrange everything. That's called the commutative property of multiplication. The order of multiplication can change without changing the value, just the way it looks. So what I've done is I multiply the 2 and the 25 to get to 50. It's typically done in math where you'll write the number before the symbol pi. That's what I've done there. And then we have centimeters squared, and that's centimeters to the first power. We use the product rule to add the exponents. That gives us centimeters cubed. And this is an exact solution. Remember that pi is an irrational number, cannot be expressed exactly as a decimal. So if you're asked for an exact solution, you'll keep your answer in terms of pi. That's what I've done here. If you're okay with an approximate solution, you can put a well-known number in for pi. We've used 3.14, and would multiply 5 times 3.14, and that gave me 157 cubic centimeters. Remember that for a volume, the units have to be cubed. For an area, it has to be squared. That's all there is for this presentation. And at the end of the day, there's only one thing left to say, and that is, that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.